Hello everyone. In this video, we're going to discuss and solve problems involving derivative of exponential function. Now, when we're dealing with exponential function, we have two cases here. The first one would be a function, alright? So for case 1, it is a function in which a constant is raised to a variable, alright? So that would be the first case, a constant raised to a variable. And the second one would be a variable that is raised, right? So that's raised to a variable. Now let us tackle the first case wherein we are given a function in which a constant is raised to a variable. Alright? So say, for case 1, say that we are given y is equal to a constant a raised to a variable u, right? So for this equation, a would be the constant and u is a function of x. Now, in solving for the derivative of this one, right, before we can solve for the derivative of this, we need to bring down the exponent here first. And to do that, we're going to take the natural logarithm on both sides. Right? So taking up the natural logarithm on both sides, we now have ln of y equals u ln of a. From the property ln of a raised to a constant is equal to constant multiplied by ln of a. Alright? Now, after getting the natural logarithm on both sides, we now differentiate both sides as well. So if we're going to get the derivative with respect to x of this side, and also we're going to get the derivative with respect to x of this side, taking into consideration that a is a constant, so the derivative of ln of y will now be equal to dy over dx all over y. And this is now equal to, since ln of a is a constant, so we can bring it out. So this will be ln of a multiplied by the derivative of u with respect to x. And solving for dy over dx, we're going to multiply both sides by y, thus giving us dy over dx equals y ln of a du over dx. Now, y is equal to a raised to u. Therefore, if we're going to substitute that one, alright, so y equals a raised to u. So if we're going to substitute a raised to u in the resulting equation here, we now have dy over dx equals a raised to u ln of a du over dx. So this is now the formula that we are going to use whenever we are given a function in which a constant is raised to a variable. Alright? Now, let's take, for example, y, or let's take, for example, the function or the exponential function e raised to u. Now, in here, we have a constant raised to a variable. So, we can use this formula to determine the derivative of e raised to u. So, say that this would be y equals e raised to u. So, if we're going to apply this formula, we now have dy over dx equals e raised to u, alright, because a raised to u is replaced by e raised to u, multiplied by ln of e, because our a in here is e, and this would now be equal to, this would now be multiplied by du over dx. Now, the natural logarithm of e is equal to 1. Therefore, the formula for e raised to u would now be dy over dx equals e raised to u du over dx. Right? So this would now be another formula to be familiar with. So to illustrate derivative of exponential functions, let's have this first example. So we are given y equals quantity 5e raised to sine of x, and then we're going to solve for y prime. Alright, so for this particular example, we are given 5e quantity sine of x, and this one is an exponential function wherein the base is a constant and this is raised to a variable, which is sine of x. So the question here is, what would be the formula that we are going to use? Since we have e, or exponential, on the base, right? So again, we have the formula derivative with respect to x of ln of a, and this is equal to a raised to u ln of a du over dx. And the other formula would be derivative with respect to x of e raised to u, and this is equal to e raised to u du over dx. Now, you might be thinking that we can use this formula directly in this given function to solve for y prime. However, this formula is only applicable for base e. Therefore, the correct formula to be used would be this one. Alright, so if we're going to break down the given function into components a and u, our a in here would be 5e and u would be sine of x. So solving for y prime, this is now equal to 5e raised to sine of x, right? So that's a raised to u multiplied by ln of a. So this would be ln of 5 multiplied by e, multiplied by the derivative with respect to x of sine of x. Right? So simplifying further, this is now equal to 5e quantity raised to sine of x multiplied by the natural logarithm of 5 times e can be written as ln of 5 plus ln of e. And the derivative with respect to x of sine of x is given to be cosine of x. So if we're going to simplify this one, natural logarithm of e is equal to 1. Therefore, our final answer would now be equal to 5e raised to sine of x multiplied by ln of 5 plus 1 multiplied by cosine of x. So this would now be the first derivative of the function y equals 5e quantity raised to sine of x. So let's have the second example here. We are given y equals arctangent of e raised to negative x, and we're going to solve for y prime. Now, the given function is in the form of arctangent of u, right? And the derivative with respect to x of arctangent of u is equal now to du over dx all over 1 plus u squared. And since u in here is e raised to negative x, then we're also going to use the formula for the derivative with respect to x of e raised to u, which is now equal to e raised to u du over dx. Right? So applying the formula to solve for y prime, this is now equal to the derivative with respect to x of e raised to negative x all over 1 plus e raised to negative x raised to 2. So solving for the derivative with respect to x of e raised to negative x, so that would now be equal to e raised to negative x multiplied with the derivative with respect to x of negative x all over 1 plus e raised to negative 2x. So this is now equal to negative, right? Because the derivative of negative x is equal to negative 1. So that would now be negative e raised to negative x all over 1 plus e raised to negative 2x. So to make these exponents positive, we can multiply both numerator and denominator with e raised to positive 2x. Alright? So if we're going to multiply the numerator with e raised to positive 2x, then the numerator would now be equal to negative e raised to x, because e raised to negative x multiplied by e raised to 2x, the exponents will add up, so negative x plus 2x will give us positive x. All over, right? So if we're going to multiply 1 with e raised to 2x, so that would now be equal to e raised to 2x, and if we're going to multiply e raised to negative 2x with this one, so that will give us negative 2x minus negative 2x plus 2x, so that will give us an exponent which is equal to 0, and any number that is raised to 0 is equal to 1. Right? So y prime is now equal to negative e raised to x all over e raised to 2x plus 1. So this would now be our final answer. Let's have another example here. We are given y equals cosine of e raised to negative 4x, and we're going to solve for y prime. So if we're going to inspect the given function, this is in the form of cosine of u, and solving for the derivative with respect to x of cosine of u, that will give us negative sine u du over dx. And since our u in here is e raised to negative 4x, then we're also going to use the formula for the derivative with respect to x of e raised to u, which is now equal to e raised to u du over dx. Right? So applying these formulas to solve for y prime, this would now be equal to negative sine of u, and since u is e raised to negative 4x, so that would now be e raised to negative 4x, multiplied by the derivative with respect to x of e raised to negative 4x. So this is now equal to negative sine of e raised to negative 4x multiplied by the derivative of e raised to negative 4x. So we're going to apply this formula, so that will give us negative so that will give us e raised to negative 4x multiplied by the derivative with respect to x of negative 4x. And the derivative of negative 4x is negative 4 multiplied by the negative sign, so this is equal now to positive sine of e raised to negative 4x multiplied by 4 e raised to negative 4x. Right, so if we're going to arrange this one, y prime can be written as 4 e raised to negative 4x multiplied by sine e raised to negative 4x. This would now be our answer. For example number 4, we are given r equals e raised to 2t multiplied by quantity cosine 2t plus 2 sine of 2t, and we're going to solve for the derivative of r with respect to t. So for this given function, t would be our independent variable and r would be our dependent variable. Now, if you're going to inspect the given function here, we have the form, alright? So this is in the form of u multiplied by v. So this one, or this expression, is our u, and this whole expression would be our v. So the derivative with respect to x of u times v is equal to u dv over dx plus v du over dx. And since we have here cosine of 2t and we also have here sine of 2t, so we also need the derivatives of trigonometric functions. And of course, we'll be having the derivatives of exponential function. Right? So if we're going to apply this one to solve for dr over dt, then this is now equal to e raised to 2t, because our u in here is e raised to 2t, multiplied by the derivative with respect to t of cosine of 2t plus 2 sine of 2t, plus, alright, so v multiplied by the derivative of u, so this would now be cosine of 2t plus 2 sine of 2t multiplied by the derivative with respect to t of e raised to 2t. So this is now equal to e raised to 2t multiplied by the derivative of cosine of 2t. The derivative of cosine of 2t is negative sine 2t multiplied by the derivative of 2t, which is equal to 2, plus 2 multiplied by the derivative of sine 2t, which is cosine of 2t, times the derivative of 2t, which is equal to 2. So this is now the derivative of this expression. Plus, we have cosine of 2t plus 2 sine of 2t multiplied by the derivative of e raised to 2t. So the derivative of e raised to 2t is e raised to 2t multiplied by the derivative of 2t, which is equal to 2. Alright, because the derivative with respect to x of e raised to u is equal to e raised to u du over dx. Right. Now we are done with the differentiation part. Let us just simplify the resulting expression. So this is now equal to e raised to 2t multiplied by negative 2 sine of 2t plus 4 cosine of 2t. And for this term, we have cosine of 2t plus 2 sine of 2t multiplied by 2e raised to 2t. Now, if you're going to notice, we can bring out 2e raised to 2t on this term, and we can also bring out 2e raised to 2t on this term because we can factor out 2 in this expression. So if we're going to factor out 2 here, we have 2 multiplied by negative sine of 2t plus 2 cosine of 2t. Right? So if we're going to factor out 2 there, we have 2e raised to 2t multiplied by the remainder for this term would now be negative sine of 2t plus 2 cosine of 2t. And if we're going to bring out 2e raised to 2t on this term, the remainder would be positive cosine of 2t plus 2 sine of 2t. Now, collecting similar terms, dr over dt would now be equal to 2e raised to 2t multiplied by negative sine of 2t plus 2 sine of 2t will give us sine of 2t, and 2 cosine of 2t plus cosine of 2t will give us 3 cosine of 2t. So this is now our final answer. For example number 5, we are given y equals e raised to 2x plus 1 all over e raised to 2x minus 1, and we're going to solve for y prime. Now, the given function in here is in the form of u over v, or it is a quotient function. Now, the formula for the derivative of u over v is equal to, right? So the formula, if we're going to recall, u over v is now equal to v du over dx minus u dv over dx all over v squared. So if we're going to apply this formula to solve for y prime, we now have y prime equals e raised to 2x minus 1, right? So that would be v multiplied by the derivative with respect to x of e raised to 2x plus 1 minus e raised to 2x plus 1 multiplied by the derivative with respect to x of e raised to 2x minus 1 all over v squared, which is equal to e raised to 2x minus 1 quantity raised to the second power. Right? So, solving further, the numerator would be equal to e raised to 2x minus 1 multiplied by the derivative of e raised to 2x, and the derivative of e raised to 2x is equal to e raised to 2x multiplied by 2, which is the derivative of 2x, and the derivative of constant is equal to 0. Minus e raised to 2x plus 1 multiplied by the derivative of e raised to 2x, which is also equal to e raised to 2x multiplied by 2, and the derivative of negative 1 is equal to 0. All over e raised to 2x minus 1 raised to the second power. Now, if you're going to notice in the numerator, we can factor out e raised to 2x times 2, or that is equal to 2e raised to 2x. And if we're going to factor out 2e raised to 2x, this term would now be e raised to 2x minus 1. And if we're going to bring out e raised to 2x times 2, in this term, we now have minus e raised to 2x plus 1. All over e raised to 2x minus 1 quantity squared. So solving further, this is now equal to 2e raised to 2x multiplied by e raised to 2x minus e raised to 2x, so this will basically cancel out, and negative, alright, so we have negative 1 minus 1, so that's equal to negative 2. All over e raised to 2x minus 1 quantity squared. So the y prime is now equal to 2e raised to 2x times negative 2, so that will now negative 4 e raised to 2x all over e raised to 2x minus 1 quantity squared. So this is now the derivative of y with respect to x of the function e raised to 2x plus 1 all over e raised to 2x minus 1.